In this tutorial, we are going to look at how to isolate an atom out of a compound. We're still in that same section of the textbook, Unit 2, under formula mass and the mole concept. So we're jumping down to the exercise number 16. This is the bottom of the page if you're under that section, if you scroll down. The question asked, determine the number of moles of compound and the number of moles of each type of atom in 25 grams of C3H6. So this problem, I chose it because I thought it was good for the wording, for you to kind of see the difference between what's being asked. You really have to pay attention in the problems what they are asking for, because it can change the problem just the slightest, and this is a good way to kind of show you that. So the first one, we're starting with our 25 grams of C3H6, and the first part of the question is asking us how many moles are in that compound. Okay, so we already talked about how to do this for the moles of a compound part. I'll just call that maybe the first part of the question. And this should be a review for us. So we had 25 grams of the C3H6. I'm going to be converting grams to moles. As per the mole conversion chart, grams to moles can be done in one step. Grams is on top, so I'm going to put grams on the bottom to cancel out. And since they're next to each other, like I said, that can be done in one step. The number of moles, according to my mole conversion chart, is going to be 1. So where moles is, that's where I'm going to put 1. And grams is going to be the mass from the periodic table. So if we add up 3 carbons and 6 hydrogens, we want to keep all of the numbers, don't round it, is what you should get for that total mass. Go ahead and solve, round our answer to 3 sig figs because we started with 3 sig figs, and we should get 0.594 moles of C3H6. Okay, so that's review. Now the second part of the question, that's where you are going to see it change a little bit. So this first part is saying, okay, if you have 25 grams of C3H6, how many moles of C3H6 do you have? Whereas the second part of this question is asking me how many moles of each type of atom are present. So instead of wanting to know for the whole compound, what's that saying for each type of atom? Well, I have carbon and I have hydrogen. So it wants me to separate out and figure out how much carbon there is and how much hydrogen there is. So this is going to start the same way. So this is, again, what we're looking at is whenever you're asked about each type of atom. That's the key difference to these. We're pulling an atom out of a compound and focusing on just how much of a particular atom is present. So for something like this, again, we have to start with what we're given, which is the 25 grams of the C3H6. We're going to, again, have to go ahead and do our conversion just like we did before to get to moles of C3H6. And I'm just going to drop that down from how we did it up top. Now, at this point is where we stopped in the problem above. But what's different in this one, again, is we're asked to pull out each atom specifically. So what we're going to introduce is a new step that's called the mole ratio. And every time you see a problem that asks you to isolate out an atom from a compound, that's a new conversion step that you have to add in to your problem. And it's called the mole ratio because it's just what it sounds like. It's a ratio of just moles. You will not find that on your mole conversion chart. This is just looking at big picture. Whenever you're asked to isolate out atoms from a compound, this is a side conversion step that you're going to have to do. So once I have where I'm at, mole C3H6 is on top, so I know that mole C3H6 has to go to the bottom. When I'm in moles, this is the opportunity that I have. to then pull out the atom. So it asked me to do both, so I can pick either one, carbon or hydrogen. We'll start with carbon. And again, to pull it out, we have to use the mole ratio of moles. So moles is on bottom and moles is going to be on top. And the mole ratio is going to be to just whichever atom it is that you're pulling out of that compound. Now, once I have my units in there, now I have to fill in my numbers. Again, for this mole ratio step, we cannot use our mole conversion chart. There's nothing on there that's going to help us. So very simply, all you're going to do, it's always going to be for every 1 mole of your compound, the whole compound. How many carbons do I see? I see 3 carbons. So this ratio is going to be 3 to 1. Okay, and then I can go ahead and solve this. Going to round my answer to 3 sig figs because that's how many was in the start of it. And that is how many moles of carbon atoms are present in this sample. Okay, so kind of the takeaway from this example, the new step that we learned is this step called the mole ratio, and we use it anytime we want to isolate out an atom from a compound. Okay, let's try doing this for hydrogen again, because it wants to know, tell me the number of moles of each type of atom present in the sample, which is 25 grams of C3H6. So for the third one, again, I'm starting with what I'm given. I want to pull out hydrogen, so in order to do that, I have to use that mole ratio step. In order to use mole ratio, I have to be in moles. So my first step is going to be to convert grams of C3H6 to moles of C3H6. Okay, and we already talked about this in the first part of the problem. Okay, now that I'm in moles of C3H6 is on top, mole C3H6 is on bottom. And I'm going to do, again, this is where I'm going to do my mole ratio to pull out the atom that the problem is asking me about. And in this case, it's hydrogen. So for every 1 C3H6, there are 6 moles of hydrogen. Right, I can go ahead and solve. Again, rounding my answer to 3 sig figs. That's what I should have. So this type of problem, again, anytime you're asked to isolate out an atom, the only way you can do that is by the step called a mole ratio step. It can never be grams to grams. It can never be atoms to atoms. The only way that you can change from the compound to the single atom is by pulling it out using this mole ratio step. Okay, we're going to do one more example here. This is actually taken from your OHM assignment number 6 on the moles. So we're going to go ahead looking at this one. Consider a 3.94 gram sample of C2H2. How many atoms of carbon are present in this sample? So again, I'm asking specifically about isolating out the carbon from this compound. So I'm going to go ahead, start with my 3.94 gram C2H2. This question, since I want to isolate out carbon, I know that I'm going to the only way I can do that is by using that mole ratio step. The only way I can use the mole ratio step is if I am in moles. So my first conversion is going to have to be from grams to moles. Okay, grams to moles, I know they're next to each other, so I can do that in one step. Grams is from the periodic table, moles gets the number 1. If you add up the mass of C2H2, you should get 26.036. Right, since I'm in moles of C2H2, this is where I can now use that step, that new step, that mole ratio step, to pull out the atom in question, which is carbon. So For every one C2H2, there are 2 carbons. Now this one asks you to go a little bit further. It doesn't want to know how many moles of carbon, but how many atoms of carbon there are. So at this point, now that I have isolated out the carbon, I can continue going from moles to atoms. That's a one-step conversion because they're right next to each other. So using that chart, I'm gonna finish it up. Moles of carbon is on top, so moles of carbon is gonna go on the bottom, and I can convert directly to atoms of carbon. According to my conversion chart, for every 1 mole of carbon, I have 6.022 times 10 to the 23rd atoms of carbon. Whenever you multiply across the top, divide by the bottom, I need 3 sig figs, and you should have the 1.82 times 10 to the 23rd atoms of carbon. If you type that in your calculator and don't get that, make sure you review back to the earlier video where I show you how to put in the 6.022 times 10 to the 23rd, how to put that in your calculator. Make sure you review that. If you're not putting it in correctly, your answer will always be off, normally by a power or 2. So